Here's a problem with that we're going to solve using the Young's double slit experiment format or template. All right, so all we have a light with a wavelength of 442 nanometers that passes through a double slit system with a separation of zero point 0.4 millimeters. And we want to determine how far away a screen must be placed so that a dark fringe appears directly opposite both slits with just one bright fringe between them. All right. So let's first try to visualize this problem. Okay. So we have the two sources, the two slits. Okay. And they are a distance D, which is given to us. Okay. And then we have a screen somewhere far. So we have one bright, it says there, and then we have a dark, we have a dark spot on either side in such a way that the dark spots are exactly opposite the slits. All right, so this is pretty much what it tells us, that these are the first dark fringes. Okay, so what we're looking for is this distance of the screen. Where should we place the screen? So once I read it and once I visualize it, now it's easy for me to write what is given. Well, it's given the distance between the slits, 0.4 times 10 to the power of -3 meters. Well, let's write it properly. That is 4 times 10 to the power of -4 meters. The wavelength, which is 442 nanometers, or 4.42 times 10 to the power of 7 meters. And then the fact that m is equal to 1. All right. What we want to find is d. Okay, so we can work around this many ways. We could figure out what is the distance and what not. However, we have one equation, right? That the distance between two adjacent dark spots, okay, so the distance between two adjacent dark spots is d lambda over d, okay, and that's an equation that we have from the plethora of equations that we derived from the double slit experiment or situation. So what we know though is that delta x is actually the same as d, right? That's what the problem is stating. That's part of our analysis actually. Okay, so which means that d is d lambda over d, okay, or that d is equal to lambda. I actually wrote the equation in the wrong way. This is d lambda over d. All right, and why did I pause? Because I noticed that the distance was going to be this magnitude of the wavelength, which is impossible to achieve. All right, so what we have is that d is d squared over lambda. All right, so the distance between the slits and the screen will be d squared over lambda. So we can find the d to be 4, which is 16 times 10 to the power of -8 over 4.42 times 10 to the power of -7. So d is approximately 16 divided by 4.42 times 10, so it's 36 or 0.36 meters. All right. So again, we started off using this equation, and then we figured out the distance between the slits and the screens so that the dark spots would show exactly opposite the slits.